So my goal today, and I guess they're not going to give me a cue to start, so we'll start. My goal today is to get everyone trying out Brokk as soon as you get back to your hotel, or maybe before. But since I recognize that I might only get 90% of you to do that, for the other 10%, I want you to still leave feeling like, hey, this was useful. I'm glad I attended that. So I'm going to start with some general principles that you can apply whether you're using Copilot or Claude Code or building something of your own, which is even more interesting. So the first of these general principles is use the right model for the job. And there's a bunch of reasons that that's hard, and the biggest one is that nobody's going to tell you what the right model is. And since we're all on, the fact that we're in this room, we're all on the cutting edge here, and that means it's up to us to figure out what those right models are and tell everyone else. And the way you do that is by writing evaluations that you can test a bunch of different models on and see who's better at what kind of task. So, I've put my money where my mouth is here. You're probably familiar with Swebench. Every time someone releases a new model, they're like, hey, we scored 80% on Swebench. Guess what? Everyone else scored 80% on Swebench too, because that's the ceiling. It's a benchmark full of 8-year-old Python tasks. Most of them are from the Django project. I should say a plurality are from the Django project. So basically, Swebench is a test of how well did your model memorize Django during the training. And if you're really benchmaxing like the Minimax crew does, then you're training it actively on the exact tasks that are in the Swebench data set. And so your benchmark result looks really good, but it doesn't generalize to other programming tasks. Brokk and I created a new benchmark that we call the power ranking, where we're looking at not just how well do these models do at tasks that they've never seen before. These are all from the last 3 months, so even the most recent models haven't seen them yet. But also, how much does it cost to solve them, and how fast are they? And so one of the things we found was that if we take all of the tasks in the power ranking and we bucket them by how large they are and look at the performance of the different models. So this is from November's power ranking. There's a new one out now, but this slide's from the November one. You can see these smaller models, they all go from being very strong at the smallest tasks to every time we double the task size, they lose about 10 to 15% of their performance. To where at the top, even the best performing GPT-5 Mini at the time, it's still down over 50% from its ability to solve these problems. Now, hold that thought for just a second. Here are the largest, the flagship models. So I was showing you the mid-sized models earlier with 5 Mini and with Haiku. Now we're looking at the flagship models, Gemini 3 Pro, GPT-5.1, Claude 4.5. And these are still losing a little bit of performance as the tasks get larger, but not very much. These are losing 10% total instead of 50% plus total. And so the question then is, why there's no problem to solve here. I just used one of the big models, problem solved. And you can do that, right? That's a valid approach for tasks that you do once in a while, or that, the effort of creating an evaluation to figure out which of the smaller models works well. Sometimes that math doesn't work out and you just use a big model and call it a day. But this is why you might want to go that extra mile and use some of those smaller models, and that's the cost. right? So it's actually, we can even look at February's models and look at what it looks like for Opus 4.6 and Sonnet 4.6. But the guideline is still the same, which is that these big models on the right are much, much, much more expensive than the small ones on the left. So if you can understand your domain well enough to use an appropriate mid-size or small model, then you're going to save a ton of money over time. And what we can do in the coding space in particular is we can use these big models to break down and decompose a coding task into smaller tasks that now the small models can tackle effectively. So this is the one slide that I did update for today, which is, so these are from last week's power ranking. And this is to show this is answering the question of what model should I use to write code today. And so this is not about what model should I use to plan and decompose. This is about having decomposed it, what model should I use to write the code. So we're graphing or charting speed, score, and value, which, the inverse of cost. And so you can see that Flash 3 is almost completely dominating everyone else. And most people don't realize this, and this is partly because, it's partly Google's fault, because they released Flash 3 with the default reasoning set to high. And when you run Flash 3 with reasoning set to high, like most models with reasoning set to high, it's very, very slow, and this looks completely different. But new in the Flash 3, in the Flash 3 release, you can actually disable the thinking, or you can set it to what they call minimal, which is it's not completely gone, but it's almost completely gone. And it just makes Flash faster than Haiku, as well as smarter, as well as cheaper. And prior to that release, Haiku was the top coding model. So it just blows my mind that Google released this model that is all three of faster, cheaper, and smarter than what was previously the best in the world. Okay, so this is what the new power ranking looks like. And there's some controversial things here, most notably perhaps that Opus is down in the B tier and Sonnet in the C tier. Those are justified. If you go to Brokk.ai and click on the blog, I've got an article explaining why this is so. The short version is that there is a ceiling on how good you can get at writing code. Like once you are at the point where you can solve all the reasonable tasks, then you're done. And now you're just competing on cost and speed rather than pure intelligence. So basically everyone's starting to push up against that ceiling, and now the fact that Opus and Sonnet are so much more expensive than everyone else, that's why they're ranked lower. The other thing that's interesting here, I guess I'll point out, Opus is ranked higher than Sonnet because when you turn on that highlight, we tested everything where we could configure it. We tested everything with minimal thinking and with high thinking. So it turns out with Sonnet, if you turn on high thinking, it will actually fail a bunch of tasks that it passes without thinking. And the reason is that it has a budget, it has a cap of 64,000 output tokens that it can generate, and its thinking counts towards that cap. So it will literally think until it runs out of tokens and then be like, sorry, man. So, and even if you retry it, most of the time it does the same thing. So we have, the harness will retry it 8 times, and if it's still not giving me an answer, then I'm just going to mark it failed, and that's why Sonnet gets a lower grade. Opus has twice the output tokens, which is why it doesn't run into that same problem, even though it does think a lot. Okay, the other thing, by the way, every time I do a talk on the measurements that we've done. Someone says, well, what model can I run on my laptop? Like, I've got a Mac, I've got this unified memory, Apple tells me it's good for running models. Like, what can I run on my laptop? And until last week, when Alibaba released Qwen 3.5, the answer was don't bother, because they're just not smart enough. The models that are small enough that you can run locally are not smart enough to bother running locally. But this is the new model, Qwen 3.5, 27 billion, and this is the other new one at the bottom center, Qwen 3.5, 35 billion. And that changed this. Like, this is the first series of models where you can say, yeah, this is smart enough to do useful work. So 27 billion is significantly outscoring Grok Code Fast 1, which was extremely popular on OpenRouter while XAI was subsidizing it. They stopped subsidizing it and people stopped using it. But like, you could actually get stuff done with Grok Code Fast 1 if you were patient about directing it exactly the right way. And 27 billion is close to Haiku. Like, it hasn't caught up, but it's close, which is extremely respectable. But it's slow. It is still slow. And the speed numbers here are coming from Alibaba's API. So I wasn't running it on my laptop. I was making calls out to Alibaba. Their hardware is such that this is about 3 times faster than you would get running it locally. And you can go pretty deep on that if you want, but the short version is your memory bandwidth limited when you're doing single batches, when all you care about is processing one prompt at a time. And that's what kills everyone, anything that you can put on your desk, that's what kills you. The Macs in particular, they have roughly the amount of bandwidth as a single 3090 video card from 5 or so years ago, whenever that was current. So that's what you're looking at. So if you imagine Qwen like over there by the door, that's about how fast it is running it locally. So it's still an issue. Speed is still an issue, but we finally cracked that first barrier, which is, can we build a model smart enough in that small of a package? And you might also notice Qwen 35B is actually faster than 27. What the hell's up with that? It's because the 27 is a dense model. So all of the layers are active for every computation through the graph, whereas 35B is a mixture of experts. So that's what the difference is. So the 35B gets you twice as fast, but also about half as smart. Not a good trade since we're already at kind of the minimum level of what's acceptable for coding. Okay, so the second general principle, leverage verification tools. And what I mean by that is, here's an example from Brokk. So I got super tired of telling the models, all the models do this. Don't check for null when it's obvious that it will never be null, right? Don't add catch exception. Like, don't do those things. And none of the models will follow those instructions because they've been trained, like it's deep in their training that if you have an uncaught exception that percolates out, then like that's huge negative points in your loss function. So they're all terrified of that, and they will not listen to you if you tell them don't do that kind of overcautious coding. But this is error prone, hooked up to nullaway. And so those are static analysis tools for Java from, I want to say, I think nullaway's from Uber and error prone's from Google, or possibly the other way around. But at any rate, they can work together and say, hey, look, this is, you're checking something that I can prove will never be null. And so I'm gonna mark that as a compile error. And the models respect compile errors. They do not respect my prompt telling them not to do that, but they do respect the compiler saying, I will not run your code until you fix this. And so I think that this redundant not null check here, that did not exist until a couple months ago when one of Brokk's engineers contributed it to the project. And so one of the things that coding with AI gives you is it just brings that barrier of entry down super, super low to where, like, 3 years ago, I would never have invested in writing a custom rule or a new rule for error prone, because it's a massive project and it is just a lot to figure out. But with the AI helping us and telling us, here's how these things work, here's what it looks like when you put it together, now you can contribute to these projects that you're already using. And by the way, this is not hey, I asked the AI to solve the problem and then I farted it out as a pull request. No, you can do that with AI, and some people do, but you can also use AI to accelerate and augment what you're doing as a human and create a much higher quality pull request that the maintainers are happy to get, instead of thinking, oh hell, like now I need to respond to another AI pull request. The last thing that's interesting is that in this world of AI, compile time matters a lot more than it used to. Because we're getting to the point now where when I'm coding with Brokk, I'm spending more time waiting for tests to run than I am waiting for the model to make changes. And that trend's only going to continue as the models get smarter and faster. And so this has implications for how you design your test suite, yes, but it also has implications for what language are you going to choose for that next project. And so my contention is, and I know this is run by the Java users group, and I respect that, and I love Java, please don't hurt me, when we had the chance to do a greenfield project at Brokk, we did it in Go, because it gives you the static typing goodness where the compiler's catching a lot of bugs before you even go to run tests, but it's also just ridiculously fast because Rob Pike is an old guy who cares about that stuff, I guess. And then by the way, the flip side of that coin is I don't like Rust a whole lot. Also, let's keep that between us because people are gonna break out the pitchforks. But aside from my personal preferences, Rust is super painful to code with AI because the compiler's so slow. So that matters a lot more than it used to. Okay, so talking about Brokk. I started Brokk almost a year ago because all the AI coding tools that I tried were really good at working on web apps and really shit at working on Java. And specifically infrastructure-shaped Java, not like web app Java. And that's because React is easy mode, and there's two reasons for that. One is just that the models have memorized the framework, right? It's a mature technology, and so it's easy to not get caught up on oh, was this feature in version X or version Y? Doesn't matter. It's all there. It's stable. But then the other is that when you're building a web app, you have your code neatly segmented by page or by route just by the nature of the beast. And so, when I'm editing something in the catalog TypeScript file, there's 4 or 5 other files that I care about, and they're all right there in the same directory, right? And same for if I'm looking at my shopping cart code, they're all right there. So that makes it really easy to solve the problem of what context do I need to make changes effectively? Because if you have a dependency on the object foo, and you know that it has a method named bar, but you don't know what parameters it takes and what types those parameters are, then it's really difficult to use correctly. In the web app world, that's not much of an issue. In the Java world, or a lot of the code that exists in the Java world, that's a much bigger issue. You have much more connected dependency graphs, both internally as well as your external dependencies. So that just makes the problem much harder for models to deal with. And in particular, everyone, it's probably too broad of a brush, but effectively everyone is treating code just as another kind of text. And I mean, that works to some degree, right? You can grep for identifiers, but this is an example from the Apache Cassandra code base that I used to work in a lot. That we have 30 classes that have a getName method. So if you're just going through and saying grep-r getName, then you're going to get back a lot of noise versus if you actually have something that is type aware and can say, no, I mean the getName on filter pipeline task and not the other ones. So that can narrow down your surface area significantly. So the first thing that we did for Brokk was build those static analysis tools that it can use while it's searching for that process of decomposing a larger task into smaller ones, and made that better than anything else out there. So now, this is the point where I do a live demo, and I sacrificed a goat earlier to the Wi-Fi gods, so I think we should be good. Let's take it for a spin. All right, so this is Brokk. It's a GUI application, and for those of you who are into such things, it is actually Java Swing. And like most, there's two things that it has in common with everything else, which is there's a box where you type your prompt, and there's another box where you see what the model responds with. Some of these other things are unique to Brokk, and I'll talk about them as we go. But I've got a fairly in-depth prompt pre-filled here because I'm terrible at typing and talking at the same time. And even if I weren't, it's kind of a long prompt. But basically what it's saying is, I've got this tools menu in Brokk. Add a tool that visualizes the project that you're working in as a graph between the objects in the code base. So I'm going to click on Loots, which is the name of our it's the easy button in Brokk. So it's going to research the task, it's going to decompose it into a list of subtasks, and then it's going to turn our coding model loose on the subtask. So you can see at the bottom I've got my planning model set to Sonnet 4.6, but my coding model is set to Flash 3 because of what I showed you earlier, that it's just the best coding model in the world. So Brokk's making a bunch of tool calls, so that's what you're seeing out there. While it is doing that, I want to show you some of the things that make Brokk a little bit different. So this is, down here at the bottom, Brokk's context. So this is what the AI will see when it goes to start writing code. And so there's two kinds of context. There's actually more than that, but we'll just call it two to start with. One is a full class. So this is the menu bar class. And then the other main one is a summary. So a summary looks like this, where we've taken our parser and we've said, hey, just pull out all the declarations. We're not looking for any implementation details, but I want all the declarations, including the private ones. We tried taking the private ones out, but leaving them in makes the models able to make educated guesses about what's going on under the hood, which is super useful. So we use those summaries very pervasively in Brokk to be able to solve that problem that I mentioned earlier of, hey, I know there's this API over there, and I need to use it in the code that I'm writing, but I don't need to edit it. I don't need to change it. If it's encapsulated correctly, I don't need to know the implementation details, and the summaries let Brokk do that effectively. Now, I can do all of this with my own code, and I can also do this in the lower left I can also do this with third-party code that my project depends on. And everything that I'm showing you can be manipulated both by me as the human operator and also by the model. So you're seeing the model go through adding in classes and summaries, but I can go in and add them myself. And just in the same way, I can go in and I can enable a dependency which pulls it into that context engine and indexes it, or I can add a new dependency, and the model can do that as well if it sees the need for it. So I can pull in autocomplete. This is one of my dependencies. And if I import that, Brokk's going to go out to Maven Central, or it's going to go out to the cargo repository if I'm working in Rust, or it's going to go out to the NPM repository if I'm working in TypeScript, whatever, and it's going to download the source for me. In Java, we can go one step further, which is if we don't have a source jar, we can just decompile it. And it turns out LLMs are almost as good at reasoning about decompiled code where all the variable names are named A1. They're almost as good at that as if it were a human readable source file. All right, so while that's thinking, check my notes. What else did I want to show you? Yes. All right, so I'm running bleeding edge code that I released this morning, and I introduced a bug that you see in the lower right, which is that it quit when the model made an invalid tool call instead of continuing to retry. So I'm just going to hit the button again and kick it off again that way. So it will pick up where it left off and keep going. So while that's going, I'll call your attention to the upper middle. So this is the activity section. And as it's been searching, you've been able to see that the activity list has been growing. And this is basically an append-only log of what's been going on in your coding with Brokk. So everything that you prompt gets recorded, but everything that it discovers and adds to the context, that gets recorded too. And so I'll show you in just a second how Brokk's code review works, but we can use that. This session activity gets synced to Brokk's servers, and so when Carlos on my team makes a pull request, and I go into the pull requests and I say, hey, let's check out this pull request here. Then Brokk's also going to bring that session information in, and when I click on help me review this pull request, then it's going to use that activity to inform the request on what was actually going on, what was the intent behind the changes that were made, which are things that, even if you have a really good pull request description, you often lose some of those implementation finer points. So that's one of the problems that we're trying to solve with that. This is a good time to talk about how you can use Brokk besides, sorry, where'd my slideshow go? Besides from this Java Swing GUI. So I've presented about Brokk a few times, and almost everyone says, hey, this is cool, I love the ideas, I like the powerful analysis tools you're showing me, but I can't get over the fact that this is a Swing application, and I just checked my watch, it's 2026, like, what the fuck? So, okay, like, I get it, I concede, I throw in the towel. There are now not 1 way, not 2 ways, but 6 ways that you can use Brokk. And the GUI that I've been showing you, this is the most mature. Everything else is in, I would say it's early access. All of these that I'm showing you, I have used to write code in Brokk. So like they work, but they're not necessarily as polished as the Swing application. But hey, like if you're, from my perspective, if you're using a text user interface, maybe you're not super concerned about the level of polish. I don't know, like it's text. So from the upper left, going clockwise, so we have an MCP server that Claude Code can use. So if you're like, hey, you can pry my Claude Code from my cold dead hands, you can install Brokk's MCP server, and that gives Claude access. It does two things. It gives Claude access to our syntax analysis. And so Claude can now search by method and say, hey, I want foo.bar method, and Brokk just gives it, and Claude doesn't have to page through foo.java 100 lines at a time looking for the method. But then the other thing that it does is that it lets Claude Code offload the coding part of what it does to Flash. And so if you're on the $20 a month Claude Code plan, you've probably run into like, oh, I'm out of tokens, right? Like I'm out of quota. And by offloading the coding to Flash, you save your subscription tokens for Sonnet or Opus, and makes it go a lot farther. And then in the upper middle, we have our own text user interface, native Brokk TUI. And then on the right, I showed you the GUI. Going down clockwise, the Z IDE. The guys at Zed and at JetBrains created this thing called ACP, Agent Context Protocol, which lets us write a single plugin for IntelliJ Inferred Z, more or less a single plugin, and it works in both places, as well as anyone else who implements ACP. Those are the two big ones that I know of so far. But then in the bottom middle, we have a fully custom plugin for VS Code as well. Just out of curiosity, who uses VS Code? Who uses JetBrains? Who uses something else? What? Cursor. All right, good answer. Good answer. Makes sense. So yeah, we've got VS Code and IntelliJ covered. So please try it out. Don't let the Swing GUI stop you. Let's see how far we've gotten. All right, so we've got a task list now, and it's started to burn through it. So we're on task 4 of 5, and it's just going through knocking those out. One of the things that Brokk does that's a little bit unusual is that we don't leave it up to the model when to run tests. We will always run tests when you make changes to the code. And so that solves the problem that I've had, and from what I've read online, a lot of people have. I can put in claude.md, always run tests when you make changes, and sometimes it just says, yeah, I'm not feeling it today. I'm just, here's the changes. I think they're good. And so, as we go through that task list, every time it completes a task, it runs the test suite or runs the relevant parts of the test suite, and then gives it back to the code agent to solve if it finds any issues. So it doesn't leave it until it's all done at the end, but rather it does that incrementally as it goes. And then, yes. This is the other thing that this activity preserves, is that every time it makes changes, I can say, show me the diff that those changes were made as it's coding. And not only that, but if I go here and I click undo, it's going to undo the changes that were made on disk, as well as pulling that out of the Brokk session. So my fear of, oh fuck, I didn't commit, and now Claude's scribbled all over my code in the completely wrong direction, like that fear is gone, because like I've got it in Brokk. I just click undo, no problem, we start over. We also auto-commit after every task. That's a little bit more controversial. About half of our users love that. Half of them hate it. So there is a flag in the settings. You just click it, turn it off. I personally think letting the model just commit as it goes, that makes it easier to digest at review time. But yeah, I'm happy to concede that that's not a one-size-fits-all thing. So why don't we take a couple minutes for questions. It's busy on the last task. And once it's done with that, I'm going to show you the Brokk code review feature. But while we wait for probably a minute or so while it finishes up that code, I'm happy to take questions. Yes?
You mentioned about coding can be done with Brokk.
Yes.
For cloud code.
Yes.
And the other planning can be done with the cloud code native cloud workers or something.
Right.
So through MCP or scripts, we can add that, and that's how we work.
Yes. So the question was, do we use MCP to provide those tools to Cloud Code? And the answer is yes. Actually, we started off building it as a skill, but the problem that skills were created to solve is actually the problem that it created for us, which is that the skills aren't always active in the agent's context. It has to say, oh, hey, this looks like something that a skill would be useful for, and then load it, and then decide to use it. So it's actually significantly less reliable at using the more powerful tools, and it will just go rip-grep for things, even though that skill is installed. So we took the skill out, and we put MCP in so that those tools are always resident, and that's made it more reliable.
And that was, you mentioned that you can do it coding. Sorry, I missed it.
Yes. Yeah. So in Brokk, the way it looks like is my planning model is here at the bottom. And then the coding model, because you don't need to change that very often, Brokk defaults to Flash 3, and you can pretty much just leave it there and be happy. Sorry, I'm talking and mousing at the same time. So if I'm in models, and then over in model roles, there's a code model here, and that's where you set that. And so the split would be very similar if you're using Brokk via MCP in Cloud Code, is that you would have the main Sonnet model driving the agentic loop and doing the planning, but then there's literally a tool called call code agent, and then that's going to go out, and then that's going to use whatever Brokk's configured to use, which is Flash 3 here.
And how about compaction, full compaction?
Context compaction? So we take a different approach to everyone else, and that has strengths and weaknesses. The strong part is that we do compaction at the task level. So all of these completed tasks, we summarize each of those at the task level and keep those in history. And so the positive about that is we have more detail about what's happened. And so when Brokk compresses its history, we call it compression, then there's no, oh fuck, like now it's forgotten what I was working on, because it has that extra level of detail. The downside is that instead of being almost completely negligible, the retained history is larger. It's like, it can get like 5% of your context window, maybe even, I think I've seen it get to as much as 10%. I haven't seen it larger than that. But like, because Brokk gives you all of the tools to control the context, I can actually go in to my full history somewhere. I guess not that one because it's still going on. But if I go in here, either I'm hitting a bug or we moved it somewhere else. But you can actually pull out independently individual turns of the conversation and say, I don't need this anymore, and just delete them out. Or of course, you can throw away the whole thing. So I think on the whole, I'm happy with the balance that we've struck. But yeah, there are pros and cons to doing it that way.
Thank you so much.
Is there a dark mode?
Yes, so I think that, I could be wrong, I think it shows up better on the monitor here. But when I'm using it not in a presentation, then I prefer like as black as possible. And then we've got a couple, in between themes. But yeah. Yep. Yeah.
Are all the features available on VS Code as well?
So everyone else is catching up to the Swing client in terms of features. Off the top of my head, I think the big one that we're missing in VS Code is the guided review. And so that's a good point to switch to that. It looks like our poor code agent is still trying to fix test failures. I'm just going to interrupt it, and then we'll go and review what it's done so far. So what this is showing me here is that this is all of my changes in the session. So you can see on the left that this is spanning the 5 commits that the agent made, but I'm reviewing those as a group. I'm not reviewing them individually. I can review them individually. I can come over here and I can click on review just this one commit. But the default is we're going to review everything that you changed, and that's the right unit of review is how it's looking. So when you ask it to review something, whether it's your own code that you just wrote or whether it's your colleague's code that you brought in from a pull request, Brokk is going to use that same context engine that it uses when it's authoring code to say, hey, what extra code do I need to look at to understand this and to be able to give you a high quality review with as few false positives as possible. You've probably worked with code review tools that they just work off of the diff, and you can see like, oh, like that's a really obvious mistake that you made because you're only looking at the diff. And so we let the review agent go in and pull in both summaries and full implementations as needed. And this is reminding me that I need to have a turbo button, mostly for when I give presentations, because when I'm not giving a presentation, I would rather wait for a high quality review. But yeah. I can show you, whoops, there it is. The other thing I was going to show you is we have here, we have a dedicated merge agent as well. So this might be the easiest way to get value from Brokk if you're, if you like whatever tools you're using, but you're like, you know what, I hate resolving merge conflicts. If you just open up Brokk and hit the button, we do a really good job, even on very large merges. All right, so the code review, the goal here is not to give you a review that you copy and paste into GitHub. The goal is to say, human supervisor, here's what I recommend you spend your time on so that you have an understanding of the big picture of what's going on, and you can drill down deeper if you need to. There are definitely people who feel otherwise, but my personal opinion is that we're not going to get to a point anytime soon where you can just vibe code everything and just not worry about what it's doing under the hood. We're definitely not there today, and I don't think we're going to get there in the next 2 years. I think what we're getting is the models are getting asymptotically closer to that, but we need some kind of breakthrough to cross that line of, yeah, I'm as good as a human supervisor. So the goal is to keep you as the human supervisor in the loop, understanding what's in your code, And because at the end of the day, you are responsible for your code. Whether you wrote it one character at a time with a keyboard, or you wrote it with Flash executing your instructions, it's still your code and you're responsible for it. And I hope that you feel that hasn't gone away. Like you still have that pride of craftsmanship, even though you've got this new AI minion helping you turn those ideas into reality. So Brokk starts off by saying, here's these key changes. And I am not seeing my code excerpts. So I think that may be because we haven't tested high contrast enough. So I'm going to switch it back really quick. All right. Here we go. So it's going to give me design issues and tactical issues. And the idea here is that a lot of the things that a review can surface is like, oh, you called map.get and you didn't check to see if your result was null. Like, okay, that's a valid thing to care about, but it's very tactical and I don't want to burn a lot of calories thinking about that. The models are really averse to leaving those out entirely, but what I can do is I can prompt it to put those in this tactical section, so then I can say, okay, these design notes, these are more important, and let's spend more time on those. So I can do a bunch of things from here, but the most interesting one is I can just say, I can read through the description and the recommendation, and if I agree with it, I can click in queue task, and you can see that a red dot appeared over here in build, and that's because there's a new task here. So it's added that to my task queue. Once I get done with my review, I've added my tasks, then I just click go again to go ahead and solve those. I can also hit the drop down and say, you know what, I don't like your recommendation. Let's take this in a different direction. So I want to edit that before we put it on the task queue. But that's what that is. Or I can just say, you know what, this isn't very interesting. It's not an issue, it's by design. I'm just gonna click next, and then I can just go through my list of if things hit that sweet spot, I'm either clicking next or in queue task, and then I'm happy with the result. One more thing, which is I've done a little bit of bragging about Brokk here. So I wanted to quantify that a little bit. So this was with Brokk's text user interface and comparing that with Claude Code. So what I did was I went through one thing that Claude has and all the other tools have that Brokk doesn't. Brokk is a coding engine. So it does not have a bash tool of set up a Kubernetes cluster for me. Like it's not designed for that. It's designed for code authoring and testing and reviewing. And so one of the things that is nice about that for us is we don't have to say, hey, do you want to give Brokk permission to do this, right? Because the only thing that it's doing are writing code in the directory that you said write code in this directory with. And so and that's to say, I did my best. I wrote a script to parse the Claude Code logs and say how long was the actual time if we take out the time that Jonathan took to notice that Claude was asking for permission to do something. So I've subtracted that out. But I gotta admit, I vibe coded that. I did not review the code that it wrote to do that parsing. So put an asterisk maybe, but I think it's reasonably accurate that Brokk came out at being roughly twice as fast and roughly half as expensive. And the interesting thing about the Claude Code side, by the way, is it's like 95% Sonnet. And partly that's because we're measuring cost here, right? So Sonnet's more expensive per token. But it really is farming out a lot less to Haiku than Brokk farms out to Flash. And the reason is that the only Haiku that goes on is when Sonnet says, hey, I want you to run this focused search for me, and I'm going to put you in charge of that Haiku because this is a task that's within your abilities. And it doesn't farm out any of the coding. And I believe, this is just my educated guess, I believe the reason is that I mentioned at the beginning, Claude depends on the model on when to run tests. And so if it's saying, hey, weak model, go write this code, the weak model might never get feedback that it broke something. And so to prevent that from happening, Claude and also Codex and everything else I've looked at, they always leave the strong model in charge of generating the code, which is too bad because that's the bulk of your expense. But because Brokk's got that testing layer built in, we can trust that Flash 3 is going to be able to figure it out. And there is an escape hatch. It can kick it back to its planning model and say, this is beyond me, help. But most of the time, the smaller model can solve those coding tasks with the feedback of the build and the test suite. So if I convinced you to try out Brokk, here's a sign-up code. This will give you $20 of credit to do something dangerous with Brokk. And yeah, please let me know how it goes. I'm pretty easy to find on LinkedIn, but you can also it's JB as in Bravo Ellis at Brokk.ai. Would love to hear from you. And nobody's kicking us out, so I think we have time for a couple more questions. Yes?
I actually checked it out, and it hurt. So.
Sweet.
Yeah.
Love to hear it.
Yeah. I had it right. Well, actually, it was funny because I didn't really have anything for it to look at. And I was like, let me just have it.
Yeah.
Write this simple thing I've been working on. And it wrote it in Python. I didn't specify language.
Yeah.
It was very interesting.
So models love Python,
Yeah.
and they also love JavaScript.
Yeah.
So one of the interesting things about our new power ranking is our first data set last year was all Java, which is okay, like that's useful, but it's more useful if you have even more languages. So now we have Java, Go, and C# tasks in our data set. And it's super interesting because, let's switch it from everything, we'll switch it to Go. So we've got a little piece of code that annotates the models on where they changed positions when you switched the data set filtering. So it's actually fairly surprising that, for instance, let's see, this one is what I was looking for. So I said right at the beginning, 35B, Quin35 is not smart enough to do anything useful, but it's actually pretty good at Go. Like, it's better than Haiku at Go. Like, I would not have seen that coming. So yeah, there's some interesting things about like who decides to put what in which data set when they're training these things that you don't know until you test it. All right, thanks for your time, everyone. Enjoy the conference.